Hey there. So in this video, I'm going to actually just be going over the practice IB problem that you guys did, just to kind of in detail, not the grading piece of it, but just the IB problem. So let's get started. So this first part of it, yay, 13 points. You're given matrix A here, right? And they tell you to write down the inverse of A, right? That's what that notation indicates. So this right here, I don't need to show work. It says write down, right? So it's 2 marks, but I don't need to show any work. So I'm going to go ahead into my calculator. I don't have to write any, I'm not going to find we actually didn't even do finding the inverse by hand for 3 by 3. So second matrix, I'm going to go ahead and enter it under A. It's all one problem, so whatever I do, I'm not going to delete it. I'm actually probably going to store it. So 1, -1, 3, 0. Nope, not correct. Just be careful. 2, 1, 1, 0, 2, -2. Okay, let's go back here. Second matrix. Recall A. Inverse is right here. Click it. Enter. Let's go ahead and write that down. Oh, wow. Got very large. I'm going to do, I know how to convert those to fractions, but I'm going to push math, enter, enter to convert them to fractions. So I've got 1. I wonder if I can just make this a little smaller. There we go. So A inverse equals -1, 1, -1, 1, -1/2, 5/4, 1, -1/2, and 3/4. I'm going to go ahead and store this. Store second matrix. I'm going to store it in B. And now it's in there if I need to use it again. So I'm going to write a note to myself so that I know that for later, right? Note to self. Cool. Right? But here, right here is my answer. Amazing. Okay, let's keep going. So matrix, I shouldn't have sorted that as B. It's okay. Matrix B satisfies this equation. Still, same A that I already worked with. I, which is the identity matrix, minus 1/2 B inverse, the inverse of that whole thing, equals to A, where I is a 3 by 3 identity matrix. Show that this is true, right? So I'm just gonna go over here and do it. So here's I. So I'm starting with I minus 1/2 B inverse equals A. So I need to forget B by itself. Well, if you take the inverse and then take the inverse again, I'm going to have isolated it, right? So I'm going to actually take the inverse of both sides. That's going to cancel out, right? It's like squaring and square rooting. It's really what's happening. So now I've got the identity matrix minus 1/2 B equals A inverse. Okay. So I'm going to go ahead and subtract the identity matrix. Now it's just algebra. So you've got A inverse minus I. And then in order to get rid of that 1/2, you got to use the inverse operation there. I'm going to multiply both sides by -2. And you should remember that it's the whole thing by -2. Then that cancels, and I've now got B equals to -2 times A inverse minus I. So on the mark scheme, you see like it says something with AG. So you writing this as the last step, like if all you wrote was one step in this, like this doesn't give you any points because the answer is given to you. Like it tells you to show this. That should be your final step. You don't get points for doing that. Okay. For the second one, I'm then asked to find B, right? So I already have A. So let's see, if I have B, let's see, B equals -2 times A inverse, which I got, right? So I've got to do A inverse minus the identity matrix. So I've got to do that -1, 1, -1. 1, negative 1/2, 5/4, 1, negative 1/2, 3/4, minus, forgot to close it, 1's along the diagonal and 0's everywhere else. Okay, so let's go ahead. I'm going to put the identity matrix in here. Let my calculator do this part. Clear. Second, nope, put it in as is. -2 parentheses. Second matrix. Yes, I can and should be able to subtract that. I'm just going to choose not to. Minus second matrix. I just stored the identity matrix in 9. Right? So then I can write that down. Sorry, now I got pretty messy. 0 to -6, -4, 0, -2, 0, -4, 6 would be my answer for B. And I'm going to go ahead and I already have something in B. I'll store it in B. Did I already screw that up? Store. Second matrix. B. Enter. So now I've stored it in B. Okay. So again, like it's so important to show your work and your process. Oh, no, I didn't want to do that. Because if I had A inverse incorrect, it's okay because I would have followed through with it. Right? Those letters F, T, look for them. So this then says write down the determinant of B. Yes, we do know how to find the determinant of B, but it says write down. Let your calculator do it. Second matrix, math, determinant, second matrix, B. Enter, enter. -48. Hence, that means use what you just did. Explain why B inverse exists. Right? So the inverse only doesn't exist if the determinant equals 0. Right? So this is non-singular. That is why the inverse exists, right? When you go ahead and you actually found the inverse, it would be 1 over the determinant times the adjoint, which is fine. That works. That got messy. It's all messy. I don't know why I'm saying that got messy. You've done a lot of work with that question like that. Amazing. And then finally, this last one, this last part says, we're still using what we have. Bx equals c, where this is x and this is c. We're going to go ahead and we're going to actually find x. So we know that bx equals c. So in order to find in order to find x, I would have to left multiply by the inverse of b. So I would have x equals, this would give me the identity matrix, b inverse times c. Let's go ahead and do that in our calculator. Second matrix, I need to enter c in there. What is that, a 3 by 1? Goodness. 3 by 1. And I've got 2. -1. 1. So I'm going to do B inverse second matrix, B inverse times second matrix, C. Ugh. Math, enter, enter. Oof, they're all rational. So C, X, well, is what? 2/3, -3/2, -5/6. Finally, it says write down a system of equation whose solution is represented by x. Huh, that's interesting. Well, system of equation. Here's x, here's y, here's z. What was b? I need to go back to what b was. Oh, I've got it right here. Okay, so this is going to be Oh, I got it. Sorry. 0x, right? So think about this is x, this is y, this is z. So you're going to be multiplying b times this. So I'd have 0 times x. I don't need to write that. That's a little silly. So I'd have 2y minus 6 equals 2 minus 6z. I don't know why I wrote a 0 there. What was a? -1. No, wait. C equals to c. I'm a mess. Equals 2. And then you've got -4x plus 0y. I don't need to write that. Minus 2z equals to -1. And finally, you'd have 0x minus 4y plus 6z equals to 1. Right? And if you were to solve this system, you would end up with these solutions for x, right? So think about how much quicker a system like a matrix equation is than some of the things you've learned about 3x3 systems, right? It's just good to have more things in your like bag of tricks to pull out. Okay, so these are some great IB style matrices. Thanks, everyone.